Okay, YouTube, in my last couple of videos, we've looked at the method of long division with polynomials. In this video, we're going to focus on a method that we call synthetic division, which, by the way, is just a lot easier to use than long division and a lot quicker to use than long division. So that's why we want to focus on it here in this video. So synthetic division, we say we can use synthetic division to divide polynomials if the divisor is of the form x minus c. So now here's the important thing. We can only use synthetic division if our divisor is a first degree divisor. Okay, so essentially it has to be a first degree divisor and it has to be of the form x minus c, but if that's the case, then this provides a quotient a little bit more quickly than long division, actually a lot more quickly. So to look at this method here, what we're going to do is we're going to look at taking this x cubed plus 4x squared minus 5x plus 5 and dividing it by x minus 3. So if we were to do this using long division, you'd see that we would have our division bar here, and inside here we have our dividend, that's that x cubed plus 4x squared minus 5x plus 5, and on the outside our divisor x minus 3. So when it comes to synthetic division, this is a little bit different, but the way it's written here is not necessarily the way I would write it. I would say that I turn my division bar upside down, and what we do is we take all the coefficients of the original statement and we insert them into this array right here. So I would say 1x cubed, 4x squared, negative 5x to the first, and 5 constants. And then on the outside of this, you notice that they have a 3 here. It says write c for the divisor x minus c. It says to the right, write the coefficients of the dividend. So we have the coefficients of the dividend. The question is, if we're dividing by x minus 3, and this is of the form x minus c, we say then what is c equal to? And the weird thing is this, we would say that c is actually equal to a positive 3 here. So we're going to put a positive 3 on the outside of this, and one way to think about it is this, it tends to be the opposite of what you see here is this factor that we're dividing by. But once we get this 3 on the outside, what we're going to do is essentially this. We're going to bring down the leading coefficient, just bring it down, bring down this 1 in this case, and we're going to multiply diagonally and add vertically. So this says multiply c, in this case 3, times the value just written on the bottom row. So we'll always take this out here times the value on the bottom row, and we say 3 times 1 is 3. Then we're going to put that up over here. So we say what we get when we multiply is put up over here. Then we're going to add these things vertically. So we'd say 4 plus 3 here is 7. Now I'm going to multiply this time the 3 times the 7 and we get 21. So that 21 now goes up over here. We're going to add vertically. So 21 plus a negative 5 gives me a positive 16. 3 times a positive 16 gives me a 48. And then 48 plus 5 is going to give me a 53. So this 53 right here, this is important that we label this, but what we just got here was essentially the remainder value. Okay. And what we end up with is a situation where if that's the remainder, then 16 in our quotient here, which this is our quotient right here, and this is our remainder, what we end up with is 16 constants, working backwards here, 7 x's to the first, and then 1 x to the second power. So putting all of our coefficients back in, we can see that these right here are really the coefficients of the quotient. And then that 53 that we see right there, we're going to write plus 53 over the thing we were dividing by, which in this case we were dividing by x minus 3. So comparing synthetic division with long division, you can see that we did all of our work in just this one little space right here. And that the coefficients of our quotient were just everything in the last row here except this last value, which is our remainder here, which works a lot more quickly than when we talk about long division. So let's take a look at these examples that I have listed here. Let's start with this checkpoint 4. It says use synthetic division to divide this by this cubic by this linear thing here. So we would say that if I'm going to do this, then the first thing we do, synthetic division wise, we can see that we can use synthetic division here because we have a factor of the form x minus c, which in this case is x minus a negative 2. So again, we're going to put the negative 2 on the outside here. Then we're going to drop in the coefficients of our dividend on the inside of this. So I have 1x cubed. Now an important fact here is that I have no x's squared. So I actually have to fill in a 0 there for x's squared. Negative 7x's to the first and then negative 6 constants. So using the same method we did last time, what we're going to look at is this. We're going to carry down this 1. We say negative 2 times 1 is negative 2. So now we'll add vertically. 0 plus negative 2 is negative 2. So then we'll multiply diagonally. Negative 2 times negative 2 is positive 4. 4 plus a negative 7 is a negative 3. Negative 2 times negative 3 is a positive 6. And in this case, when we add these, we get 0. So the fabulous thing here is that we actually got a remainder of 0. And then the other nice thing about this is what's left over here is we have an x squared minus 2x. I'll go ahead and write negative 2x. Minus 3 is our quotient here. and we would say plus the remainder of 0 over x plus 2, which doesn't necessarily need to be written in this case because we had no remainder. So we'll use synthetic division as we go forward, but also comment on the nature of that remainder value in the next video. Cheers.